If you're a student looking for universities to study material science or materials engineering, ASU is going to be probably one of your best options, not just because of its size, so it can support so many different research cores and facilities, but also everything surrounding it. There's battery research, solar cell research, semiconductor research, anything that you may want to pursue once you graduate. But even more than that, the faculty is really wonderful. They're all heavily invested in research.
One of the things about ASU is being one of the biggest schools in the country, we have great personnel resources in terms of faculty expertise, and we have great experimental resources for doing your research.
Phoenix is the hub for semiconductor industry, and ASU has got one of the biggest grants from Department of Defense to actually develop workforce for the semiconductor industry and also invest in equipments that are being used in the industry.
If you want to engineer the material for the future, you need to understand how that material is structured, what it's made of, and how it functions. And so we have access to great resources here at ASU. For example, one of our shared labs is called the Ira Materials Center, and it has a suite of electron microscopes that cost millions of dollars, and you would have access to them for your research and education if you decide to come to ASU.
It's amazing to have such a great facility in a state school, and that motivated me to come here. I had competing offers at other places, but I chose to come to ASU because of this very reason.
The professors are really quite involved in trying to make sure that you get the absolute maximum out of your education, but also that you have as many opportunities for hands-on experience as you can. And that's probably the most crucial thing. Whether you're going to go into academia or whether you're on track for industry, hands-on experience and just knowing what it is that you want to do is going to make all the difference.
Faculty advisors are very hungry for research. They are motivated. At Arizona State University, we have a vibrant community. Students learn from each other, faculty learns from each other.
A lot of times students are underconfident and they don't know what their true potential is. So my role as an advisor is to push them to realize their true potential and do stuff that they could not believe they could do when they came to the group.
The way I try to help students succeed in research is to provide a venue where they have few to no roadblocks. I don't want to be that roadblock, but also I want to give you an opportunity to meet other researchers, other students, because I think that's the most important part, is that we build this community of scholars, thinkers, and intellectuals.
At Arizona State University Material Science and Engineering, we have a strong alumni basis. These alumni you will see are actually one of the most successful in the nation. Some examples would be Charles Kuhlman. He is one of our graduates and he is the materials division lead at SpaceX. Other graduates, they often take leading roles at Honeywell, designing new kind of materials, or Intel, designing new kind of electronic devices. Some of them actually became faculty members at UT Austin or Northwestern or University of California.
Ultimately, ASU was my choice because the semiconductor industry was growing, and that meant that there was going to be a lot more opportunities for corporate collaborations and career opportunities, frankly. So whether you want to study microscopy or a material's optical properties, its electronic behavior, its magnetic responses, there is going to be some sort of shared tool. In fact, there's probably going to be multiple versions of a shared tool that research scientists are going to help you get trained on so that you can use it. And it's really fantastic. It's a really efficient way to go through your research so that you can really pursue it in depth to a degree that you might not be able to at other universities just because they sort of can't support research cores to the degree that we have here.